Welcome back again to the PLC Professor's Workshop Lab, where we develop our training collateral, our training materials. We come up with our lab projects. This is another lecture in the advanced series, and this one is a project that we're going to use for some other advanced subjects. So if you've already done the basic course, then you've probably already done this lab project or one very similar. But we're going to go through this lab project to make sure everybody understands it before we start doing other advanced subjects. But we need this program, this little virtual conveyor system to work with in order to demonstrate. So let's take a look at this program. Welcome to the next video in the series of videos that are lab discussions that support the complete PAC Learn series and Introduction to RS5000. This particular lab was called Conveyor Code, quite a lengthy discussion. This is part one. We are actually in the process of going through tasks, programs, routines, and add-on instructions as far as their structure and their relationship to each other. In the previous discussion, we had said that in order to have multiple programs, you at least have to have some code to put into those programs. So we're going to create some code based on an application, but first we're going to explain the application. Here we have a conveyor system, and there are 3 conveyor sections. They are driven by 3-phase 480 volt AC motors, probably with variable frequency drives so you can control the speed. Now we could also control the speed directly from the PLC, but in this case we're going to do a very simple application. Cartons are unloaded off of a truck and placed at the top of the gravity conveyor, and they roll to the lower end, coming to a rest against one conveyor's leading edge. In other words, they roll into photo I1 but not photo I2, so they come to rest against the unmoving leading edge of the second conveyor, one conveyor. Photo I1 senses a carton present at the exit of the gravity conveyor. 2PE does not sense a carton until one conveyor is energized and the carton is pulled onto the conveyor. 3PE, photo I3, senses a carton at the end of conveyor 1, one conveyor. And 4PE has the same function for 2 conveyor that 2PE has for 1 conveyor. Both 1 conveyor and 2 conveyor, as I said, are motorized and controlled via outputs from 2 different controllers. So we don't actually control the motor that drives 2 conveyor. That's controlled downstream. However, what we do get is an aux contact in the other control system that controls 2 conveyor. That aux contact comes back to our system, and when that contact closes, we know that they've turned on 2 conveyor. We have a possible selector switch, I say hardwired, for on and off. The reason that I did that is because this application can also be used with the 10.IO RSLogix 1000. Has 6 inputs and 4 outputs. Well, we have 4 photo eyes. We have 1 conveyor powered. But for inputs, we have 4 photo eyes, 1, 2, 3, and 4. And then we have the jog push button, and we have the aux contact. That's 6. That uses up all the inputs. So we marked the selector switch 1SS as hardwired. However, this is the Logix engine, and in our applications we're not working with a 10-point RSLogix, so that doesn't have to be hardwired. Now, remember, the content of this manual is aimed at those who have at least the experience of the previous lab project manual, which was titled the Complete PLC Learn series. However, in consideration of time that could have lapsed between having finished RS500 base labs and this manual being available that you are now using today, we will include more detail than necessary to bring everyone into the mindset of programming, including a detailed lineup of this material handling process. So this is our conveyor, and there's many ways that we could program this. Really, the conveyor that we are controlling is one conveyor. So we're actually only controlling one conveyor. And that conveyor, if you look at it, it looks like it could be 6 foot long, could be 4 foot long, could be 8 foot long. Just depends on how wide the conveyor is. But the main idea is to act as a buffer. In other words, cartons come in by gravity, and then they're pulled onto one conveyor, one carton at a time. And then when the conveyor is completely full of cartons, we say that that conveyor is buffered. In other words, its buffer is full. And the reason that we're buffering cartons on one conveyor is when 2 conveyor calls, then we want to feed cartons out of that buffer. There's 2 ways that you can use that buffer conveyor. You can stack up cartons on it because downstream is not calling for cartons, and then when the downstream process calls for a carton, 2 conveyor turns on, and we get the aux contact from 2 conveyor. And if there's a carton on one conveyor, we can feed that on through, and since 2 conveyors running, it'll just pull it on and on it goes. And then if 2 conveyors shuts down, but cartons are still being unloaded from the truck onto the gravity conveyor, we can stack them up on one conveyor. There's 2 ways of looking at it. One conveyor can either buffer unloading the truck, or it can buffer cartons when 2 conveyors not calling for cartons. And it may sound the same, but it's not. There are 2 ways that you can run this little section of conveyor, but you don't have to run it just one way. In other words, you can have 2 completely different functions, or as many different functions as you like, for this little section of conveyor, depending on whether you're unloading the truck or you're calling for product downstream. And it's simply a matter of logic that the operator selects truck unload mode, and one conveyor and its logic behaves one way, and then once the truck is unloaded, flip the switch back and it becomes a slightly different function. And there's some other, you can have cartons that are being pushed off to the left. In other words, if you go over to the left of the gravity conveyor, you could have a conveyor that's going perpendicular from the bottom of the screen towards the top, and when a certain carton comes by, it's pushed off onto the gravity conveyor and comes down onto this conveyor. So we'll just stick to something basic though. Okay, so here's our conveyor, and as you gathered, product is going from left to right. We're going to change the graphics slightly, mainly because the upper graphic I created a long time ago, and the lower graphic is something that I created in the manual. You probably recognize this from the manual. But it's the exact same application. You have photo eyes 1, 2, 3, and 4. You have gravity 1, conveyor 1, and conveyor 2. You have the exit of gravity, the entrance of one conveyor, the exit of one conveyor, the entrance of 2 conveyor. So it's the exact same application, same names. And of course, product is flowing the same direction. You can't go up a gravity conveyor. However, you could be feeding conveyors off of 2 conveyor onto one conveyor and have the product going from right to left, and the gravity conveyor actually is higher at this end and lower at the other end that's fading to the left. But we're going to stick to having product going from left to right. Okay, so there's our empty conveyor. They're unloading a truck. Here comes a carton down the gravity conveyor, and when it breaks photo I1, the controller knows there's a carton sitting there. There's nothing blocking photo I2, and the logic knows that one conveyor is empty. Now, you could program it so if 2 conveyors are running, then that carton, one conveyor fires up, pulls it on, and sends it right across because it wants product. There's a couple different ways you can do the logic, but we'll just do one for right now because remember, we're doing multiple programs, not conveyor logic. Okay, so it pulls a carton on. If we went backwards here, in the bottom illustration here, the carton is resting against one conveyor and it's not moving. Now the one conveyor turns on and it pulls the first carton through photo I2, and in the logic, as soon as photo I2 clears, you stop one conveyor. In the meantime, another carton is rolling down the gravity conveyor. When it gets down there, it breaks photo I1 and it comes to rest against the stationary conveyor, one conveyor. And the logic then says, well, there's only one carton on one conveyor, it'll hold 4. It starts up one conveyor and it pulls that carton that was resting against its leading edge through photo I2. In other words, it turns on until the carton breaks photo I2 and then continues to run to the trailing edge of that second carton. Then it stops. Here comes another carton down gravity. It breaks photo I1, comes to rest against stationary one conveyor. However, because there's still space on one conveyor turns on, pulls the third carton through photo I2. In the instant that photo I2 goes clear, one conveyor stops. Here comes another one down the gravity. It comes to rest against one conveyor. Because the one conveyor is still only has 3 on it, it turns on and pulls the fourth carton onto one conveyor. As soon as the carton clears, one conveyor stops again. Here comes another one down the gravity conveyor. However, 2 conveyor is not on. So there's no place for these cartons to go. So at this point, it's stationary. But the system knows that there is a carton waiting to go on to one conveyor if one conveyor turns on. So if one conveyor turns on and takes a carton away, it pulls on that last carton, and now there's 4 again on one conveyor, and here comes another one down the gravity. Okay, so in this case, there are 4 cartons on one conveyor. 2 conveyor has stopped, so the cartons just stack up at the lower end of one gravity, with one unblocking photo I1. But again, they're not going on to one conveyor because one conveyor can't run because 2 conveyors not running. Okay, so 2 conveyor takes off, and when it does, it pulls a carton. Well, one conveyor turns on because 2 conveyor turned on. So we get the aux contact from 2 conveyor. One conveyor turns on. A carton breaks photo I4, so now we know that one has left, and of course the one that was sitting against the edge of one conveyor over at the end of gravity, it gets pulled on. And the gravity conveyor is of course slow to react, so that other carton doesn't follow right against the back edge of the carton that's being pulled onto one. So that's basically the application. As you can see that once one conveyor is full, you won't be able to turn it on unless 2 conveyors turned on. So if 2 conveyors running, then we know that if there's any cartons on 2 conveyor, they're moving away to the right, so we can turn on one conveyor and start feeding cartons on 2 conveyor. Now sometimes they run these at different speeds, depending on whether you want to increase the space between the cartons or decrease the space. We purposefully singulated the cartons on one conveyor by controlling the logic in such a way that one conveyor pulls one off at a speed faster than the next carton can fall by gravity, and so the carton that is being pulled onto one conveyor just clears photo I2 and one conveyor stops before the carton can get down against the leading edge of one conveyor. Consequently, the faster one conveyor runs, and of course where we put photo I2 would determine the space in between the cartons. Now when the cartons leave one conveyor, if 4 conveyors going faster, then it's going to spread out the space between the cartons as they go on to 2 conveyors. So that really wraps up our project description. Now we're going to continue on into the actual logic to run this conveyor section. And remember that this is conveyor code, but this is part of multiple programs, which is part of the section called Tasks, Routines, Programs, and Add-on Instructions. Okay, back we are to our programming. And when we left off, we had done this little bit of, what would you call it, virtual I/O. So we're going to save this and start a new project. So we'll click on the save symbol and say, yes, let's upload the tags, upload the data table. And now it's saved. So now I'm going to close down this program and create a new one. So I'm going to go File, New. We'll leave it a L35E. We'll make it version 20, and we'll call it Conveyors. Just for, and I didn't have you do this in the lab book. I think you probably just continued on with the program you had, but I'm going to do a separate one. That way I could go back to my other bit logic if I wanted to for another project. So I'm going to call it Conveyors, click OK, and it's going to create the project. There's our new project. If we look at the controller, there's really nothing to change. We could change the controller. We can't change the rev level at this point. So we're going to leave it as is and start from here. So let's open up the only routine we have, the main routine. So double click. It gives us a rung, so we're going to throw in a true if on, and an energize output. And we're going to call this System Run Enable. You see I abbreviated a little, and I use upper and lower cases to give me a type of delimiter in the text to make it more readable. So Sys Run Enable, that's pretty clear, System Run Enable. And the next one we want is to Conveyor Running. To C-O-N, to Conveyor Running, and run one conveyor. I just picked, if I had run one CON, you might come up with one condenser, one contactor, you'd come up with something else. Now that we have this much added, we need to define these tags. The first one we're going to define is run System Run Enable. Right click, New System Run Enable, and we want to make this a base Boolean, and we want it in the program. Okay, so the name of the controller is Conveyors. We want it in the main program files. Now if you accidentally put it in the other one, that's fine. You can cut and paste from the controller tags into the program tags. Okay, and I had you look over all of this new tag definition box to refresh your memory. Leave everything as is and click on Create. This action assigns a Boolean memory location that the tag Sys Run Enable points to. Okay, so now we have a defined tag. This one, however, is undefined. We will accept this one with the defaults as the previous. Now, the reason we can go ahead and accept it is because since we last choose scope, main program, that's still there. So we can just go create. You can't put a number as the first character in the tag name. So I'm going to put in an underscore. That's very common to see underscore as the first character. That way people can use what appears to be a number as the first character, but it's really not. It's an underscore. So click on Create. So I'm glad that popped up. See the underscore there? So we've covered those bases. We need to start somewhere, so we say that if the system is enabled and to conveyor is running, then run one conveyor. Now, if there's no cartons on one conveyor, you still may want to run one conveyor if two conveyors running. That way, if two conveyor is running, that means it wants cartons. So downstream, the system is being starved for cartons. So if two conveyor comes on, you probably want to run one conveyor regardless. That way, if a carton does come down the gravity conveyor, it goes right on to one conveyor, and keeps on trucking until it gets onto 2 conveyor. That is actually a good feature since we're feeding the downstream demand. Okay, and run 1 conveyor, we'll make that the same as the rest of them. If we don't like it, we can go change it later. So we'll just say new. It's already in program tags, so we'll say create. Now we want to add another piece of logic or another instruction, and it's a compare. And so this will greater than, and we're going to put in a tag 1 conveyor count. Okay, underscore 1 1 conveyor count. We don't need to put an actual source B in yet. We're going to make that a new tag, and we're going to leave it as a dent in the main program and say create. As long as the ops bit from 2 conveyors on, the downstream process is calling for cartons, and if the carton count on 1 conveyor is greater than 0, our material handling system will feed cartons on a 2 conveyor. So how do we count cartons onto 1 conveyor? Now remember, this sounds like I'm contradicting myself, but I'll show you later how to add code to bypass this limitation of greater than if we want to just leave 1 conveyor running regardless of whether or not there's any counts on it or not. So this is a dent, that's a Boolean, a Boolean. Now we do have to put a value in here or a tag. We'll just put 4 in for right now. Or we'll just put in 0. Okay? That way if it's greater than 0, it's going to be true. Let's stop and review what we have for a second. This is very common conveyor control code. We have a bit that we can toggle on and off called system run enable, and you really don't have to have that, but it gives you some kind of on-off control for the logic in general. If the system's not enabled, then you don't want to run anything. So that's just a major on-off toggle bit. And then of course the actual logic begins with 2 conveyor running. Now something I noticed when I paused for a second was that I wasn't consistent with my abbreviation. So I'm going to go back here to 2 conveyor running, and I'm going to alter this. Now I'm offline right now. I don't have to put the rung in the edit mode to start working on it. Now, see, there's no E's right here. I can just go click on that tag. Now this is a good opportunity to emphasize something about editing a tag versus creating a new tag. If I just click on that, put the cursor between the N and the R and put in a V, see how the E's popped up at the head of the rung? That's because that is an undefined tag. Well, wait a minute, that was 2 CON running. Well, it's not anymore. I just created an undefined tag. If I wanted to edit the tag, you don't just start typing and changing the name of the tag. If you do that, you're creating a new undefined tag. So instead, we're going to undo that. See, the E's disappeared the minute I use the undo button up there. And I'm going to right click and say I want to edit that tag. Now if I go here and put in a lowercase v, and of course you can't see the bottom of the screen where it says apply and OK. And the reason you can't is because I've got this set for 720p for HD. I could probably make it 1080p. The problem is it wouldn't fit on a lot of people's screens, not in its natural resolution. So we'll just have to put up with every once in a while not seeing what's a little bit below the capture area on the screen. That was one thing I wanted to do, was to make this consistent, CONV for conveyor. And One of the nice things about RSLogix 5000, it is actually easier to maintain consistency than it was in RS500. In RS500, you basically, every time you created something, you were doing it from scratch, where you will see later on in this lab that it's real easy to reuse things even with the same tag name, and there's because of the isolation between one program tag database and another. Okay, the other thing that may have confused you as I was hem and hawing in adding this code in is that I said it might be a good feature that if two conveyor is running, because remember, two conveyor is the downstream conveyor that you don't control, not in this particular application. Two conveyor is a conveyor that is controlled by the downstream process, and when the downstream process wants product, it turns that conveyor on. And then you have an aux contact from two conveyors motor starter. You have an aux contact that comes back to your panel for your controller. Now, when you do that, if there's voltage coming from another panel to your panel, the insulation on the wires is always amber or orange, basically saying caution. In this case, you're running two wires over to their panel, and they will also be yellow or orange. You didn't need to know that, but it just popped into my head, so I threw it in there. So anyway, two conveyor running is not something you control. It's a condition that you are acquiring from another controller from a downstream process. So if two conveyor is running, you could rename that, we want product, we want cartons. Whatever it is you're supplying, the downstream part of this system, it wants it. So you could call that product request. However, the way that it requests the products, it turns on the conveyor, gave you access to the aux contact, so you know that it wants product. Now, in the old days, we might have run one conveyor continuously or turned it on and off with two conveyor. In the green days of today, where you're more energy conscious, why run one conveyor if there's nothing happening? So this greater than, if there's a carton on one conveyor, then it's going to turn on until you count it off. And so you can change the value of source B. And just to make this more interesting, source B could be a tag, and the value in that tag it's a variable. Remember, tags are variables. 0 is a constant. So right now, source B 0, that's a constant. And you can't change that without putting the rung in the edit mode to do that. Now, we're offline right now, so you could just type in any number you want. But if this system were running and you decided you wanted 4 cartons on that conveyor before it fed any off, then you would have a 4 in there. However, because cartons are different lengths, you might be able to put more than 4 cartons on that conveyor if you're buffering cartons. So based on the length of the carton and the spacing in between, you might say that a full conveyor or a fully buffered one conveyor is 6 cartons. So you would want source B to be 6. Rather than having the operator call a maintenance person or an engineer and say, yeah, we need 6 cartons on that conveyor for this product, instead you would make source B a tag, a variable, and then you would make that tag accessible from the HMI, your human-machine interface, man-machine interface, your screen. And then on the screen you could go and change that number, or when they select a different product to run in the whole system, part of the recipe management, if you want to call it a recipe, or the setup, would be to automatically move into the tag in source B how many cartons you wanted for a full buffered conveyor. Okay, so the greater than just gives us the ability, based on conveyor count, to control whether or not one conveyor runs when 2 conveyors is running. How do we count cartons onto one conveyor? Well, we're going to have to use the photo eye to count cartons onto the conveyor. We're going to need another rung of logic, so there's many ways you can do that. If the focus is here, if we click, it'll drop it down below, it'll append it. We don't want it down there, so we could grab it and move it up to here. However, in this case, it would have been simpler. Now I'm going to hit the delete key. The focus is on this new rung. Hit the delete key, it's gone. It would have been easier if we had to come up here anyway to click on it, to just grab it and drag it down to the rung Mimi. Remember I said all these little things here are saying pick me, and drop it because we want it on top of that rung of logic. Now we could have this next rung of logic as the second rung. It doesn't have to be rung 0, but typically you like to do your logic so it kind of reads in the order that it executes. Since here we have an instruction that says if the conveyor count is greater than 0, well, we want to create the conveyor count. We're going to put it in the rung above. So we need something, an event, to increment the count. So I'm going to go up there and put in a true if off, and then for a tag I'm going to have underscore 1 PE. When 1 PE is not blocked, we're going to increment the count. You'll understand in a second if you don't already. Now we're going to introduce a instruction that we may or may not have used before in this manual, but we used it a fair amount in the RS500 series, the complete PLC Learn series. And that is a one-shot instruction. So it's in the bit tab. So we grab a one-shot, drag it down, and then for the tag name, we're going to call it one-shot. Now with 500, I would put a 1 after this. That way I could have more than one tag or more than one variable called one shot. So I'd have one shot 1, one shot 2, one shot 3. Sometimes people make it a little bit more descriptive. One shot conveyor count up, so you know what the one shot is for. I typically don't do that. So I'm going to put in decimal point 1, and you'll see why in a second. Hit enter. Now that's an undefined tag. So I'm going to right click and notice that here it says undefined tag one shot decimal point 1. But when I right click on it, it just says new one shot. It does not acknowledge the decimal point and anything after it as part of something you can define as a tag. Now I'm doing this on purpose for a reason. So we'll say new, and then we're going to make it a dent, so we can just type in DI there, and when it comes up dent, go ahead and click create, and now we have a tag one shot dot 1, and that is a legitimate tag because it's the second bit or bit 1 of a 32-bit double integer. However, we don't want to waste the first one. Some people don't like zeros. They think 0 means nothing. But you all know by now that 0 is always the first in anything computer, and 1 is second, 2 is third, and so on. At first that's a little confusing, but after a while you don't tend to think of 1 as first. You just think as 1 as a number that represents something. So we're going to edit this tag. The tag already exists, so we're not, I guess we're not really editing the tag. We're just going to pick a different element. So we're going to backspace and put in 0, and so now that is the first bit of the tag one shot. So one shot is a 32-bit double integer, as you can see, and 0.1 or 0.0 is the first member, the first element, the first bit of that 32-bit dent. And so every time I want to use a one shot, I will just go and look to see what bit has or has not been used. So if we double click here, drop down. Now look, you see anything different about those numbers? There's 32 of them. 0 through 31. So you see the bit 0 is used, right? It's grayed out and kind of recessed graphically. If we had used already one shot dot 0, 1, 2, 5, 15, and 29, they would all be grayed out. Not grayed out, but they would be, it would be emphasized that they were already used. So as you're creating one shots, you just go pick one that's not used. But all the one shots are in one place. They're in that 32-bit dent. Okay, we'll hit escape because we're satisfied with what we have. Now, instead of using a counter instruction to count, we're going to use an add instruction. So we're going to go up here to our tabs. Now there's two ways you could do this. You could double click here, go right here and type in ADD. Oh, we'll do that. And hit enter. There's your add instruction. Or you can do it I don't know if you want to call this the hard way or not, but scroll over to the Compute Math tab and drag it down. Still going to end up in the same place. So what we want to do is use this tag right here that we already defined. Click on it, drag it up to here, and then from here, click on it, drag it down to here. And then we'll put in a constant of 1. So every time this code executes, it will increment the one conveyor count by 1. Now, we still have ease over here. That's a good tag. That's a good tag. So it must be which? This one right here. Right, we never defined it. So right click, new. We want it in our main program. We wanted a Boolean, even though it may end up alias to an IO later. We'll just go ahead and create it. So the rung is happy. So now every time one PE is not blocked for one program scan only, the add instruction executes. And it takes one conveyor count, adds one, and puts it back in one conveyor count. This is very typical logic for counting, using an add instead of a count up instruction. I typically use add and subtract and not count up and count down. There's some other characteristics of counters that I don't like. I use counters anyway, but I'm just saying I typically use add and subtract with one shots instead of count up and count down. Now, in the manual, when you got to this point, it had a little description of this rung, and on this instruction it said on the trailing edge of a carton leaving 2 PE. One shot the add instruction. This increments the count each event of a carton clearing 2 PE onto 2 conveyor. You probably have seen the error we mentioned, actually clearing 2 PE onto 1 conveyor. So it's not an error as far as code writing goes, it's a less than optimum logic. So if you remember the diagram for the conveyor, 1 PE is the exit of the gravity, 2 PE is the entrance photo eye. Even though when the carton clears 1 PE, you one-shot the add instruction, you could say that that carton is more or less onto one conveyor. But it would be better to not count it as being on the conveyor until it actually clears 2 PE. We could go edit this tag, but we're going to need this tag anyway. We're going to go up and create a new tag. To do that, we just double click there, backspace, put in a 2, that becomes an undefined tag, and then we define it, just like we did the rest of them. Now, this logic is much better. 2 PE blocked, not, so true if off. When 2 PE is blocked, then we one-shot the add instruction. If you're new to PLCs, you're probably thinking, well, if the photo eye is not blocked, it's just going to sit there and add. Well, no, it's not. It's a one-shot. The first program scan that this true if off instruction is true, it's going to one-shot the add, but this isn't going to execute again until the photo eye goes back on and then off again. So this is catching the trailing edge of the carton to execute the add instruction to increment the one conveyor count. Now we're going to need this exact same logic, or very similar, to count cartons off of one conveyor. So we're going to select that rung just by clicking at the header on the rung, and then you could do right click copy, right click paste, or from your keyboard you can go Control C, which you can't see what I'm doing on the keyboard, and then go Control V. That's the same as copy paste. You should all know that from working with word processors. Now we have two identical rungs, but we want to modify them because this is going to count down the count. So the first thing we'll do is we'll change the add to subtract. To do that, you just double click on add. Now you could type in SUB, or you can go down to the list of instructions and find it. So see, you have access to all the instructions here. So we'll select subtract. Now we have to change the one shot, because if you were going to do this properly, we know there's only bit 0 used. You would double click, open up the bits, and pick the next unused one. Now, what photo eye do we want to use to say that when it sees the trailing edge of the carton that it is off of one conveyor? Well, you could use 3PE because that's at the exit, but it's still hanging over the edge a little bit. It cleared the photo eye. I mean, it's not truly on one conveyor, it's mostly on two conveyor, but it's better to use 4PE. So we'll change that simply by double clicking, putting the cursor behind the 2, backspace 4, enter, and now we have an undefined tag. Right click, new, create. Okay, you see that's just a little shortcut that I use both to create the one-shot dent. I just went ahead and typed in what I knew I wanted, one-shot dot something. Now I made it one-shot dot 1 and changed it to 0 just to show you some editing. But typically you would have typed in one-shot dot 0 and then created the one-shot dent, and dot 0 would automatically have been a defined tag. And so you can see the difference between creating a new tag and editing a tag. If you just start typing in something different here or editing the text, you're creating a new tag. But if you right click, edit the properties, then you're editing the existing tag. Okay, so now we have logic that counts cartons onto one conveyor and then counts them off. And here we're using that value to determine whether or not to run one conveyor. Okay, now let's save this and download it. So we go up to the floppy disk symbol that remains to this day for save. And now we're going to go to communications, who active. And as long as we're here, I'm going to show you something that I haven't showed you before. We've been using an RS232 DF1 driver. And if you drill down, there's the processor. If I select the processor, you see that this is active. You can go online, upload, download, etc. But I continue to drill down, and now you can see everything else. Notice that when this is selected, that this is active. When this is selected, it's not active because that's not the processor. And I did explain that to you before, that you're going in through the RS232 port, which is the bottom port on that processor. This is your computer. This is the cable going to the controller, the front of it. And then this is the back of the controller, the back plane. And on the back plane, you have the controller, the Ethernet or the NIC, the network interface controller, and you have a local bus adapter. Now it's all one piece of hardware as far as you're concerned. It's all in one plastic case. But I wanted to remind you that this is not the controller, this is. So this is your hardware image, but they put a graphic placeholder in here for slot 0 so you know what's there. Now, I added an Ethernet driver, so I'm going to expand this one. Notice how different it looks. I'm going from my computer by way of an Ethernet cable to the Ethernet port, which is this device right here. Okay? And notice that my computer now shows up as a placeholder, graphic placeholder. Workstation, and this shows the IP address of my computer. Now I'm going to expand this because we're coming into the NIC, into the Ethernet hardware. If we go through the Ethernet hardware, we go to the back plane. And then on the back plane, we have the controller, the placeholder for the Ethernet card, and then the bus adapter. But look at the plus signs. Look up here. No plus sign in front of the processor graphic placeholder. No plus sign in front of the graphic placeholder for the Ethernet card. So notice that this is the controller up here. We go right from the computer to the controller by way of the cable. But here we go to the NIC, then to the back plane, and then over to the controller. So this is more typical of what you see. See up here, grayed out, and nothing here is going to make that part of it active. Come on, computer. Connecting to device. Give me a break. Wish I hadn't clicked on that now. So I've done something to confuse it, so now it's trying to reconnect. This is really RSLogix. There's nothing wrong with RSLogix. It's a phenomenal piece of software that works. But because RSLogix has to connect to everything, you can't control everything else. You can only control the Rockwell hardware in RSLogix. We'll go back up here and click on that driver. See, now this is active. We'll go down here and click on this processor, and it's active. So now we're going to download. Now I have already told you, read this once, but in the future you don't need to read it. It's just kind of a warning that always pops up. Okay, we're done downloading. Change the controller back to the remote run mode, yes. And now we're running. And you see the conveyor count is 0, right? And none of these are I/O tags. 2 PE block, 4 PE block, system run enable, 2 conveyor running, run 1 conveyor. Those would be tags that are alias to real I/O tags. But we have not done that yet. None of the photo eyes are blocked. So the first one that would be blocked is 2 PE, because that's first, you know, it's 1 PE, 2 PE, 3 PE, 4 PE. We'll go toggle that to say that it's blocked. Okay, so right now there's a carton in front of 2 PE. Now, when the carton passes through 2 PE, it is no longer blocked, and notice that the one shot exercised, and we added 1 to 0, and we now have a count of 1. See, so one conveyor count is now 1. If another carton comes in and blocks, remember that's true if off. So right now it's unblocked. So let's block it. Nothing happens. Only when this goes true does the one shot exercise the add instruction. So now we're going to clear the photo eye. In other words, the carton went on by, cleared it, and see, now we counted up to 2. Okay, we'll do that a couple more times. 3. 4. So now we have a count of 4 in there. So now if we feed cartons off of 1 conveyor onto 2 conveyor, then this photo eye will be blocked, but you see nothing happens. See, it's still 4. And then when we unblock it on the trailing edge of the carton, as it clears the photo eye, it counts down. Okay, so now we've got our count up and our count down onto the conveyor. And here we're using that. If it's greater than 0, then we run 1 conveyor. The reason you don't see it running is because the system run enable is not on. We'll toggle that on. And yet it still doesn't run because the downstream conveyor, conveyor 2, is not running. We'll pretend that that's running. Now you see that one conveyor is running, and as long as we have this greater than 0, and of course we can run, we're running one conveyor, right? It's running, 2 conveyors running, so cartons are moving. So let's run a bunch of them through. This time we block it. See, we still got a count of 1, right? This is still true because it's greater than 1. When it clears, the count goes to 0, and now one conveyor is not running. 2 conveyors still running. Okay? If you wanted one conveyor to run, whether there were any cartons on this on one conveyor or not, you could put logic around the greater than. We didn't have you do that in the lab, but since we're here and we're talking about it, we'll remember we're running, we're in remote run, so we'll double click here to put this rung in the edit mode. We'll click on greater than, we'll click on the branch around, and then we'll put a bit in here. Go to our favorites, or we could go to bit or favorites, and we'll call this one conveyor rinse. Rinse is a term typically used in a sequential or a system that has product going through it continuously, but something happens and you want to stop running, but you want to finish everything that's in process. We refer to that as rinsing the system. In other words, we're getting rid of everything that's left in there, so we're removing the conditions that are needed to keep it going under normal circumstances. So that's not a tag, so we define it as a Boolean in the main program. We'll go up here to finalize all edits, say yes. Now, if I turn that bit on, now you see one conveyor is running. And it'll run regardless of the conveyor count. So, but cartons will still count on and off. So if we come up here and we block the photo eye, then unblock it, it still counts up to 1. Okay, so cartons will still count on and off of that conveyor. It's just that we'll run one conveyor anytime 2 conveyors calling. If all of a sudden downstream they don't want anything, then they stop that motor, and our aux contact that we're looking at is no longer feeding us an on signal back, so our true if on is now false, and we don't run one conveyor. So this is some pretty simple logic. I'm going to take out this one conveyor rinse because it's not in the lab project, but I mentioned it, so I thought I'd go ahead and show you, and you could see it's nothing complicated. One thing we have not done is shown how to get cartons onto one conveyor in the first place. So we have nothing that tells one conveyor to run to pull cartons off the gravity conveyor. So let's add that now. We only have one OTE, output energize, for run one conveyor. This will initially, it will eventually alias to the real IO tag that actually controls the motor for one conveyor. So we have to work within the confines of this rung. So what we're going to do is put this in the edit mode. Then we're going to come up here and drag down a branch around, and we'll come all the way around to here. Now the reason we're bypassing 2 conveyor running is because this piece of logic determines when one conveyor runs based on 2 conveyor running. And by the way, you can cheat a little here. I probably shouldn't do this, but we're in the run mode. So if I come up here and grab this and drag it down, I'm not going to be moving it, I'm copying it. See, if I drag this down to here, it's still there. But if you were in the offline mode, you would be moving it. It wouldn't be here anymore. You would have moved it down to here. So you got to be careful when you're doing this. Now, we want this to be 1 PE. I know that I already have that tag, and if I didn't, backspace 1 enter, then I would have to define this as a tag, but we already defined it. Remember, this was, we originally had 1 PE here, and then we changed it to 2. This tag is already defined. When 1 PE is blocked, and I also, even though this is a true if off, I wanted to show you something else. Double click on it, put the cursor behind the O, backspace C, enter. So now you have a true if on. So there's a lot of little shortcuts that help you write code just a little bit faster. If photo I1 is blocked, that means we have a carton ready to come on to one conveyor. However, we don't want a carton to follow another carton right onto one conveyor, so we want 2 PE cleared, not blocked. Okay? So I probably could have just left that down there. If 1 PE is blocked and 2 PE is not blocked, then there is some space at the beginning of one conveyor to put a carton. However, what if one conveyor is already full? Well, how would we know that? Well, we have to know how many cartons one conveyor can hold, because remember, we're not going to run this normally unless 2 conveyor is calling for cartons. And we want it to clear 2 PE before we actually count it as on the conveyor. So every time a carton comes onto one conveyor, 2 PE will clear. So we can't tell by looking at this photo eye how many cartons are on one conveyor. We only know that there's not one in front of 2 PE. If 1 PE is blocked and 2 PE is not, then the transition from the gravity to one conveyor is clear. However, we also need something to say whether or not one conveyor is full. We go up, and there's a number of ways you can do this. We go up to the compare, and we grab a less than. So if the one conveyor count, we just drag it down there, that's the easy way of copying it, is less than 4, because we had determined at one point that 4 was the most that that buffer conveyor could hold. Now remember that if we end up doing something where we want a full buffer, then these two numbers would probably be the same, and they might be a tag that gets changed in the program based on the size of the carton that is being transported through the system. Now our logic reads, and we'll just ignore this because this is the general on and off bit. If 2 conveyor is calling for product and there's something on one conveyor greater than 0, then run one conveyor. That feeds cartons over to 2 conveyor. Or we want to run one conveyor if it's not full, 2 PE is clear, and 1 PE is blocked, meaning there's one ready to come on. Now, there is a little problem here, and it's the same problem we had before with when is the carton actually on the conveyor. So we're going to go ahead and run this because that's what we did in the lab, and then we'll go back and add a little bit more logic to make it better. So here we have right now we have 1 carton on there, right? Okay. If 1 PE is blocked, watch run one conveyor here now. We'll toggle that bit on. So now one conveyor is running and it's pulling a carton through 2 PE, so we'll pretend that it's blocked. But at some point, watch this, look what happened. The minute we blocked 2 PE, we lost our one conveyor. So where's that carton sitting now? Remember, 1 PE is blocked and 2 PE is blocked. Well, if it's blocking both photo eyes, then it's sitting right across the gap between the 2 conveyors. That's not what we want. So we need to keep one conveyor running. We need to start it if 1 PE is blocked and 2 PE is clear. But once it blocks 2 PE, we want to keep it running until it clears 2 PE. So let's look at our code. This is all we're concerned about, is this rung right here. Now, we want to run one conveyor if there's a carton available and the count is less than 4. And we know that it's not going to count up, increment this number until it clears the second photo eye. So if we go down here and we put that rung in the edit mode, but we don't want to do that because that'll move it. I was trying to cheat. So I guess I'll just have to do it the hard way and put it in there and then drag the tag down. Okay? So the way this logic reads now, and there's many ways to do that. If you have a better way, that's cool. Now, if 2PE is blocked, we're going to, and it's less than 4, we're going to run one conveyor. So you're thinking, well, then it would run all the time. Well, no, it won't, because remember, if you're running one conveyor and there's a carton sitting in front of 2PE, it's moving. And at any instant, it's going to clear 2PE, the trailing edge. It's going to increment the count. When it clears 2PE, and this is now true, that won't be true unless there's another carton ready to come on right behind this one. And there's already space in between them. So that's okay. So as long as the count is less than 4, and this logic is met, we want to run one conveyor to put cartons on it. In the lab, I had you step through this logic by exercising the photo eyes in a specific order. I'm not going to do that here in the video, but I think you can see that, you know, you did the lab, so you know it works. So if we, right now, 1PE is blocked and 2PE is blocked, which means the carton's halfway across, right? So the next thing that would happen is it would clear 1PE, but the conveyor keeps running until it clears 2PE, and then it stops. Notice when it cleared 2PE, our count incremented and it stopped. When another carton comes along, it runs the conveyor, starts pulling it on. As soon as 2PE is blocked, that goes false, but because this went true, and this is less than 4, it keeps on running. Then eventually it will clear 1PE, and then eventually it'll, and watch this count right there, 2, and eventually it'll clear 2PE, and now we counted up to 3. So here comes another carton, gets blocked, goes across, blocks 2, clears 1, clears 2. Here comes another carton. But wait, it's not running because this is now not less than 4. It's full. It won't run. So you see, the logic is really simple. This is the part right here that sometimes throws people. They think, well, why not just have 2PE in there? Well, you can't get, this would never run the conveyor because you have to run the conveyor to get 2PE blocked. Okay. While we're at it, we'll add a little bit of production data. No pun intended when I said add. Put that rung in the edit mode. And then we could go right click, copy, right click, paste. That's a way to get another add in there. Or we could go up here and drag it down. So what we want is, we want to make this production count. And we'll make it a double integer, create, and then take and bring it down here. So now these two add instructions are always going to execute basically simultaneously. In real time is a fraction of a microsecond apart. So every time we count one onto the conveyor, conveyor 1, we're going to increment our production count. But we're never going to decrement the production count. We're counting cartons on and off of conveyor 1. With the second and structure, we're just counting. If, and of course we'll make this 4, no, this right here. We'll make this 4 so it matches what we've got on there so far, even though we've run more than that. I just want to demonstrate something here. Watch what happens when 2 conveyor calls for cartons. It runs 1 conveyor, right? Now, when 2 conveyors running, 1 conveyor is running, when it clears, it blocks 4 PE. Remember, that's on 2 conveyor. When it clears, that counts down to 3. Now, if 1 conveyor stops, 2 conveyor stops calling, we're still running 1 conveyor because we're pulling 1 on, right? In other words, we made another carton available. So 2 PE is going to get blocked. And then 1 PE will become unblocked. And then when 2 PE, watch the count there, it's 3, goes to 4. Go back up here, notice this is 5. So this is the cumulative count of cartons that came onto 1 conveyor. Okay, we're going to add a couple more rungs of logic that we did in the lab. So I'm going to knock in 2 rungs. And then I'm going to grab a Truephon, a 1-shot, and I want to clear. Now, I could go down here and get a clear. I'm going to double click here, go up to here, and type in CLR to get my clear instruction. Here, I need a Truephon, a 1-shot, and a move. And again, well, we'll just go down here and find it. There it is, move logical. Whoop, I double clicked. So we're going to create a couple new tags here. This one will be reset production count. Reset production count. And this one will be change 1 conveyor count. And here we need a 1-shot. I can type in an O, N, comes up 1-shot. And I could simply, because I already know that I've used 0 and 1, I could just go .2 and hit enter, and I'm good. Here I need another 1-shot. I'll type in an O, N, but I'll click here, go down there, and pick the next unused. Now, we want to clear the production count. See, reset production count. Here we want to correct the 1 conveyor count. We'll create a tag here called, that's a double integer, create. That's a Boolean, create. That's a Boolean, create. Now, the E's disappeared, now we have I's. When you're online and these rungs are good, in other words, it likes the syntax and everything looks good, it goes to an I, a lowercase I, which means insert. It's ready to insert into the code. So I'll finalize all edits. And in the manual, I says, I'll give you one guess, or take your best guess at what the purpose of these 2 rungs are. It's evident. Reset production count. If I toggle that bit, it's going to clear the production count. Change 1 conveyor count. Now, if you happen to walk by this conveyor and you notice that there's only 3 cartons sitting on the conveyor, or 2 cartons, or 1 carton, or no cartons, but there's some sitting waiting to go on at the end of the gravity conveyor, you know something's not right. You would go to the HMI and you would bring up the run screen that shows this section of the process, and you would see that the count on that conveyor doesn't match what you see with your own eyes. So when you look at the graphics, it says there's 4 on it, but when you look, you see less than 4, which means that if you let this continue to run this way, it's never going to have 4 on there. So the system's not functioning correctly. So what you can do is enter in the corrected amount. So you go here, let's say that there's, well, first let's say that, well, it says there's 4, okay? Okay, so we'll leave that alone. I didn't mean to change that. It says there's 4 on it, so it stopped. But the count is really only 3. You put a 3 in there. When you hit this button, it's going to move a 3 into that count. I just thought of one more thing that would be good to add. I'm going to, on the end of this instruction, I'm going to add a clear, and I'm going to clear the corrected count. That way it's not a remnant for the next person that's using it, because someone comes along and pushes that button, it would move a 3 in there. Let's say we want to correct the count from 4 to 3. We put a 3 in there from the screen. You can't see it, it's below, but down here is toggle bit. See, it changed it to a 3 and it cleared the corrected count. So that's just a little housekeeping tacked on there. There's little things like that you can do that clean up code to make it run cleaner. If you put 3 in there and press the button, it would clear the count that you put in there, the corrected count. Now remember, this corrected count can work for any conveyor. Corrected count is just a number that you enter from the screen. So you could duplicate this logic, and it has a button that says change to conveyor count, different one shot, and then the move says corrected count destination to conveyor count, and then clear corrected count. It's just one register, corrected count, but you can use it in many rungs of logic. I had no intentions of making this video this long. I like to keep them no more than 30 minutes maximum, hopefully 20 minutes. I could break this up into 3 pieces. However, I think I'll just leave it as it is. Thank you for watching. An introduction to RS5000. Conveyor code is just one piece of the manual. If you happen to get to this video without going through all the ones before it, you're in the wrong spot. But nonetheless, there's information to be had just by watching this one video. This is going to be followed by more exercises that involve multiple programs and tasks. So this is just a small piece of something that's continuing. Thank you for watching part 1 of Conveyor Code. That particular lab entitled Conveyor Code was broken up into 4 pieces. This piece you just watched. The next one that you want to watch is called GSV, Get System Variable, but it's probably not marked as part 2. The third video lab discussion, will be called probably production data, and then the 4th piece, reusing the code. Thank you for watching.